Okay, so you understand about structure, and I just mentioned again that for every program, right, it is a combination of three basic structure here: sequence structure, work everything in order from the first statement to last statement, right? You have the selection structure; it break it down into branches, right? If condition true, you work with something, and if the condition not true, you work the other thing here. And you can have the dual alternative or single alternative, right? But loop structure, you keep doing it again and again, such a repeat action here, right? Until the condition is not true here. Every program, it is a combination of three structure. A sequence number, you work in the order, right? And selection structure, you work with branching, right? And you see, in the selection structure, you have the dual alternative. That means you have the condition here to check, right? If true, you do something. If not true, you do other thing, right? Or you can have the single alternative. Right? If the condition true, you do something. If not, don't do anything. Right? And for the loop, you only have the condition to check again, right? If the condition true, keep doing it again and again and again until the condition not true, right? But one thing I just want to highlight again when you work with the Raptor here, the Raptor a little bit confusing because in the Raptor, whenever condition true, you exit the loop. That's why you have to pay attention when you convert it from the serial code to the Raptor. Right? You remember that in the Raptor, whenever condition true, you exit the loop. But in every other programming language, in the real programming language, if the condition true, you keep doing it until the condition not true. Right? And you see, in my slide, I have everything for you. I have the code for the Raptor, and so I have the code for the Python here. You can look into that for your reference. And you have the combination of the structure. Every program is a combination of the three structure here. You can see you have sequence and selection and the loop, and you can net it together. You can put it inside each other here. You have later on when you work with many programs, you can see for this one. Okay, now also this also very important when you understand the mainline logic. Using the priming input. Priming input is the process you initialize the variable who control the loop. Right? So what you normally do with the housekeeping module here, right? And in the program, it's a very simple program. You do not have to work with modularization. But remember, if you work with the loop here, it should be better. You have to work with the priming input. And remember, priming input is only you have to initialize it before and outside the loop. Before and inside the loop. So we have the sum of the example for this one here. What's wrong with this program? What do you think? What's wrong with this program? You know that you got the input from original here, you check the condition, but at the end, you have the action to get the new value of the variable to control the loop. That three rule, that remember three rule when you work with the mainline logic here. You have to identify what is the variable to control the loop, right? You make sure that you have to initialize the value of the variable who controls the loop outside and before the loop. The third rule is that remember you only have to get a new value of the variable who controls the loop inside the body of the loop. That's all. Everything you have to follow three rule. Follow the three rule. Okay. So not much for this week. I mentioned about the random function with the Raptor already, right? Because some of the Raptor program require you to work with the random function. And if you are not clear about random function, just let me know. I explained it already. And so I have the program here. Right? And if you're not clear, you can read my slides again. On this week, you go. Now, I want to go with some of the homework for this week. Oh, I see. Number 3. Oh, I think so. Number 3, I need to have one more slide here. Because you have to work with the base number in your work. Right? So now, Okay, now you work with the data representation. So the first thing you should understand about the decimal and binary representation. So decimal, everything you work normally, right? For each digit, you have the 10 value. It can be 0, 1, 2, 3, 4, 5, and 9 here, right? But for the binary, it only have, for each digit, you only have the 2 value, 0 and 1 only, right? 0 and 1 only. And underlying of every computing processing, we only work with binary system only, 0 and 1, right? That's why you have to understand about the binary here. Now, you should understand about the base and exponent, right? So we think about, in the case the base here, when you have the 10 raised to the power of 2, you understand that 10 here is the base, right? And this one, number 2 here, is an exponent, right? So actually, when you have the 10 raised to the power of 2, the process is 10 times 10, right? And if I have the 2 raised to the power of 3, that means I have 2 times 2 times 2, 3 times, right? And 2 here is the base, and this one is the exponent. Now, you go on with the decimal system. So when you work with any system, digit system, you have to understand about the position of the number here. Right? So think about this one here. If I have the number 999. Now, if you look at this one, you have 3 digits. You have 3 digits here, right? All of them, they have the same digit. All of them, they have the 9 digit here. But the value is not the same. Right? This number 9 here, the value is in the 1 column. Value here is number 9. Right? This one here is the 10 column. So actually, you have to times 10 for this one. The value here is 19. Right? And this number 9 here is the 100 column. So the value of that one, you have to time it to the 100. You have 900. Right? So see, even that digit is the same, but the value is not the same. And you have to pay attention to the position of the number. Right? So in order to know what is the value of the position here, you know that for the first column, that is the decimal by 10, right? So that's why you have 10 raised to the power of 0, you have number 1. That is the 1 column here. The second column, you have the 10 raised to the power of 1, you have number 10 here. That's why you have the 10 column. Right? And so on. You have 100 column, 1,000 column, and 10,000. Right? That's why you see, when you have 99 here, actually you have 9 of 100. Right? You have 9 of 10, 90 here, and you have 9 of 1, you have 9. Make sense? Okay, that when you work with the decimal. Now, when you work with the binary here, it follows exactly the same with the value of the column here. But the only difference here is the base. Now it's base 2, not the base 10 anymore, right? So you see, with the binary system here, you see, now it's the base 2, base 2, base 2, base 2, right? So the value of the first column, again, raise it to power of 0, you have 1. You know that any number, when you raise to power of 0, you have number 1, right? Only 0 raised to power of 0, you have the, not any number. But any number, when you raise to the power of 0, you have number. So you see, the first column here, you have 2 raised to power of 0, you have 1. The second one, 2 raised to power of 1, you have 2. The 4 and 8, 16, and so on. Right? Okay, that's all. So now see, let me ask you a question. If I have the number in the binary, I have numbers 1, 0, 1, 1, 0, 0, 0, 1. Can you tell me, if I have this number in the binary, what is the decimal number for this? What's the decimal value for this? Now tell me. You work with the column value here. What I have? What's the decimal value I have for this one? It is the same. Number 1 here in the 128 column, right? So you time it, you have 128 here. This one, you have 0 here. This one, you have 32. This one, you have 16. This one, you have 0. You have 0. You have 0. And you have 1. And you sum it up together. You sum it up together, right? You have the 160, 176, and 177. That's the way you convert it from the binary to the decimal. That's all. You have to remember about the column position here. You have to remember as a column value here. This one column 128, this column value is a 64, and so on. Make sense? So normally in the computer, they group every 8 bits together in 1 byte. In 1 byte. That's why you see you have the first, you have 2, you have 3, you have 4, you have 5, 6, 7, 8 byte. So 8 bits. And the group together, they have 1 byte. Make sense? Okay.
So,
now,
I guess my question would be, so power 2 to the power of 7 is 128. Why would the 1 also be 128? Like at the bottom in the binary representation.
This one?
Yeah.
No, binary representation is only 0 and 1. Right? The digit binary, only 0 and 1. Okay. Yeah. So now see, if I have 0 here, I have 1, and 0, 0, 0, and 1 and 0 here. That is a 8 bit here in 1 byte. So now tell me about this one again. What is the value of this binary number in the decimal?
So 0, 64, 32.
Yes. Yes, that's all. Okay. You just sum it up together, right? You have 0 here, you have 64 here, you have 32 here, you have 0, 0, 0, you have 2 here, and here's 0 here. And you just sum it up together. Just sum it up together, you have 98. That's the way you convert it. And of course, nowadays, you can use with the calculator. You do not have to do it manually, right? You can do it with the calculator. So when you work with the calculator, you go with the programmer, right? So we think about this one here. I enter 0, right? I work with binary. I put binary. 4, 1. See, in the binary, only have the 2 options here. 0 and 1 here, right? 0 and 1. So you can convert anything with this one. So see, if I convert it 0, 0, 1, 1, 1, 1, 0, 0, I have the decimal city. Okay, that's the first thing. You need to know how to convert it from the binary to the decimal. All you need to know, you have to remember about the column position here. 1 double it, 2 double it, 4 double it, 8 double it, and so on. Okay. So that's the way you convert it. That's the way you convert it into the from the binary to the decimal. See, it's right. You just remember about this one. This one here is 128, right? This one here 64, 0. This one 32 here. This one 16. This one you have 8. This one you have 4. This one you have 2. And this one you have 0. And when you sum it up together, you have 170. Make sense? That's the way you convert it from the binary to the decimal. And you know that, remember that. All you need to know is to understand the process. And even that, if what happened here, if I have the bit number 9, right? So I have 2 raised to the power 8, I have 256 here, and so on, right? If I have number 10, I have 2 raised to the power 9, I have 520, and so on. Make sense? Okay. Okay, now you know that how to convert it from the binary to the decimal. What is the reverse process? What happens if you want to convert decimal back to binary? What happens if you want to convert from the decimal to binary? So basically, you follow exactly the same. You have to follow exactly the same, right? You think about this one here. If I want to convert now, if I want to convert number 172 here, right? If you want to convert to the binary, you have to work from the left to the right, to the left to the right, right? So see, in order to make it up for the 172, for sure I need 138. Right? So if I need 138, I put the number 1 here. Now I will have 128 here. Right? That's why I have to minus 128 this one. Right? So I have 44 left. Right? Now, in order to make it up for the 44, I don't need 64. That's why I put 0 here, right? And in order to make it up for the 44, I need 32. Right? That's why I put number 1 here. That's why I have 32 here. And again, I have the minus 32, which is 1. Now I have the 12 left. Right? In order to make it up for 12, I don't need 16. That's why I put 0 here. In order to make 12, I need 8. That's why I put 8 here. I minus 8 again. I have 4 left, right? In order to make 4, of course, I need 4 to make it. And now I minus 4, I have 0. That's why I have 0. That's all. That's the process. You convert it from decimal to number. You do it from the left to the right. That's all. Make sense? And of course, you can do it. You can do with the calculator anytime you want. However, you have the calculator. You do not have to work manually. I just think about, I have number here. I work with the decimal number, right? I have 170. I convert it. I know that I have 550. That's all. That's the way you work with the calculator. Now, some of the program also, they work with the hexadecimal system. So what is the hexadecimal system? Hexadecimal system, they use base 16, not by 2, not by 10 here. 16, that means for 1 digit. For 1 digit, you have 16 value. Right? For 1 digit, you have 16 value. You can have everything from 0, you can have everything from 0, 1, up to 9. It's a 10 value already, right? Now, you can think about A, it's the same with the 10. You have B, it's 11. You have C, 12. You have E, 13. D. D is a 13. E, you have 14, and you have F. You can think about 15. Right? So see, you have everything from 0 to 15. So basically, you have 16 value for each digit. Right? That's why they call it is a hexadecimal base of 16 here. And again, if you want to convert it from the decimal to the from the hexadecimal to decimal, or from the decimal back to the hexadecimal, you follow the same rule. You have to understand about the column of each position here, and the value of each column here. Now you go back to this one. You see, they follow exactly the same rule. I follow exactly the same rule. Now you have the base 16. That's why everything here is 16. Right? So the first column always raised to power of 0. You know, have 1, raised to power of 1, you have 16. 2, you have 256, and so on. That's all. That's the way. Now, tell me, if I have number 27 here in the hexadecimal, can you tell what is the value in the decimal? 27 in hexadecimal. 27 here in hexadecimal. Can you tell what is the number in the decimal? You follow the same rule. Now, guys, tell me. I have many of you online here. Tell me. If I have the 27 in the hexadecimal, what is the value in the decimal? You should follow the same.
32.
What is it?
Oh.
No, okay. Now, if you have 27 here in the hexadecimal, the first thing you see, number here, number 2, right? The column value here is a 16. You time it together. Sorry. You time it together. Oh, where? How's this one? Here. You time it together, you have 32. Right? Number 7 here in the column number 1. You time it together, you have the 7 here. And you add them together, you have 39 in decimal.
Oh.
That's all. You just follow the process. You have to understand about the value of the column. Make sense? Okay, now I have give you another example here. If I have the number B2 here, tell me what is the value in the decimal?
34. 34.
34.
B would be 2, right?
No.
Oh.
2 is a 2. A is 10. B is 11.
Oh.
right? B is 11. So actually, for this one, you have to understand that this one, you have to take 16 times 11. That is the value of this one, right? And this one, number 2, you add them together, right? And you have the 178 here. Make sense? That's the way you convert it. Right? You just remember about the position and the value of the column. Make sense? So again, I just want to explain about the process when you convert it here, but everything you can use the calculator. But some of the program you need to code it, so you have to understand the process of converting. Okay? So see, everything from 0 to 9. Huh? A, you can think about 10. B is 11. C is 12. D is 13. E is 14. F is 15. Okay? And you see, you follow exactly the same rule here. If you have 3, 6, B, what is it? 3 here, and that is a converting back. Sorry. So now the process of converting the decimal number. Sorry. What? Yeah. That's the process of converting the decimal number back to the hexadecimal. Right? So again, you follow the same process. You do everything from the left to the right. Right? So see, if I need the 875, I don't need this one. I don't need so much here, right? That's why I put 0 or I don't put anything. Now, in order to make it up for the 875, I need this guy. Right? I need 3 of them. Right? That's why I need 3 of them, right? So you can go back here. You have 800 divided. I need 3 here, and remaining 107 here. Right? So after this step, I have 107. I move it back. In order to make for 107, I need 16 here, right? I need 6 of the 16 divided here. I need 6 of the 16 and remaining 11 here. Right? And 11, you know that 11 is B. Right? So see, I need 3 from them. I need 6 from them and 11 from them. Right? That's the process you convert it. You convert it from the decimal to the hexadecimal. The same, you work it from the left to the right. Right? Make sense? Okay, the process, if you convert the hexadecimal to the decimal, you work exactly the same. You follow the rule. What is the value of the column? What's the value of the column? Value of the column. You time it together. Right? Time together. You add them together. You need 1 of them, 2 of them, 3 of them. D here. What is it? D here is the 13. Right? That's why you add them. Any questions so far? It's very, very simple and straightforward here. But again, I said, you understand about the logic. Otherwise, you just work with the calculator. Huh? But it should be better you understand the logic here. Any question, guys? Hello? Now, you can work with the hexadecimal notation. Right? So we see, if you have the 4-bit of binary, now the thing about you have the hexadecimal, right? Hexadecimal, each of them you have the 16 values. 0, 1, 2, 3, 4, 5, 9, A, B, C, D, E, F. Each of the digits you have 16 values. And in order to represent for 16 value, you need 4 bits. That's all. Right? Because the thing here, you have 2 raised to the power 4. You have 16. That's why you need 4 bits in order to represent any hexadecimal. That's why you see you have all of 0 and so on and so on, and all of them number 1. Right? And when it converts them, you see, if all of them number 0 in binary, you convert them, you have number 1, and so on. That when you convert it to the decimal, and that's why you convert it to the hexadecimal. So basically, in the decimal and hexadecimal, everything 8, 9, from 0 to 9, they are the same, right? But 10 here is A, 11 here B, and so on. Okay. I want to explain the process here because in the homework, you have some of the process with the conversion here. Okay, now, basically for the hexadecimal notation, when you have the series of the hexadecimal notation in the computer, basically, if you want to convert it into the into the hexadecimal, you just group 4 of them together. Because one hexadecimal you need 4 bits, right? So you need 4 of them together. You just group them 4 of them together, right? So see, you have group of them, and group of them, and group of them, so on, right? So see, you can look it up in the table. You know, this E, this one A, this one is 0, and this one everything, right? You can look it back in the table here. You can see everything. You can look it back in the table. See what is it? 1 1 1 0 here. 1 1 1 0 E. Now what happened is 1 0 1 0 here. 1 0 1 0 here. Like so on. You just look it up. Or for me, I just convert it to the decimals, and then I know what is it. Now, the second part here is the integer representation. Integer representation, right? So we know that integer is everything about the whole number, right? Only the integer part. We do not have the floating point number here, right? So integer can be stored as the unsigned number, that means non-negative, right? So think about everything here. Unsigned number. So what is it? Unsigned number here. You can see you can have 0, 1, 2, 3, and so on. Right? Or you can have the sign number also. You can have -5 or -7 here. Okay. And also for floating point number, you also have the several variations. I will explain it later with my class. Now, the first thing about the integer, you understand about the unsigned integer format. Unsigned integer format, everything non-negative. Everything non-negative, right? And normally for the computer, it processes information in the form of bytes. And 1 byte, you have the 8 bits here, right? So see, if you have 1 byte, you have 8 bits. And you have 2 bytes, you have 16 bits, and so on. And so on here. Now, binomial in the group of 8 here, right? So see what happened here. If I want to store the 1 1 and I want to store 1 0 1 1 0 1 here, basically in the computer you have to store it in the 1 byte. So what happened here? If I want to store 1 1 here in the 1 byte, so basically I have to put 1 here, I have to put 1 here, and every other I have to make it up to the 8 byte. I have inserted for the 6 0 here. Make sense? The same with this one. I have 6 here. So in order to make it up for 1 byte, in the computer, they have to insert 0 0 here to make it up for 1 byte. Make sense? Okay. Make sense now? Yeah. Just do it by adding 0 to the left of the number to fill it up many space here. So that is called unsigned format of integer because only store for the non-negative number. Now think about this one here. For this one, what happened if I want to enter, if I want to store the number 200 here into the 1 byte? What do you think? What is the problem? If I want to enter, if I want to store the number 300 into the 1 byte memory, I'm not able to do it, right? Because you see, the 1 byte, the maximum value that you have 8 of them number 1. 8 of them number 1 is maximum because 1 byte, 8 bits only, right? And when you convert it to the decimal, you only have the 255. Right? So in that case, they call it overflow. They call it overflow, right? So in that case, if you want to store 300 here, actually you need 2 bytes. Right? Make sense? Okay. That in the case that you do not have enough memory to store number, that's they call overflow. Right? And you cannot store number 300 in 1 byte. You need 2 bytes for that, at least 2 bytes. Right? Make sense? Okay. So see, that is unsigned binary integer, right? So to store the decimal number 5 in, to store the number integer number 5 in 8-bit memory here, location here. The first thing you have to convert it into the binary, right? convert it into binary. The second one here, you store it in the 1 byte, right? You need to add it up for the pi byte on the left to make it 1 byte. Make sense? Okay. Now for this one, of course, this one you cannot store it in 1 byte. You need 2 byte or 16 bit here, right? And of course, when you convert it here, and you have to add the 0 on the left to make it into the 16 bit here. Make sense? That's all. That's the process you store it. So basically, if you want to the computer store the unsigned binary integer, it's just to convert into the binary, and insert number 0 on the left to make it up to the full memory location. Make sense? Okay. Now that is a case of overflow. I mentioned it. It's a case you do not have enough memory to store the number. Right? In that case, it's called overflowing. So that is range of the unsigned integer. Is that if you have 8 bits, you can store everything from 0 to 255. Right? Because the thing you see that you have 8 bits, you have 2 raised to the power of 8, you have 256. That's why it's the range from 0 to 255. And you have the 16, you can store the range up to the 65,000, and 32, you have the 4 billion, and 64, and so on. Right? Any question so far? So I think we should take a short break, and we come back, take a short break for 5 minutes. Okay, so you have the range of unsigned integer here. Now my question here: what happens if I want to store? What happens if I want? What is the way I want to store the number 12 into the decimal, into the 8-bit memory of the unsigned integer? How will you store it? Number 12. How we store it in the 8-bit memory? What is the process and how we represent it? The first step, you have to convert it into the binary. You can convert it, so you have number 12, that means you have 8 here, you have 4 here, you have 0 here. Make sense? That this one 8, 0, 4, is this one 2, and this one. So I have the 1, 1, 0, 0 here. I store it in the 8-bit memory. That's why you have to add 4 0 here. That's all. And of course, if I want to store it in the 16 bits, I have to add more 0 here on the left. That's the way you work with the. That's the way you work with the unsigned integer. It's very simple. If you want to work with unsigned integer, you just convert into the binary, right? And you put it in the memory, and you insert the number 0 on the left to make it up for the full memory location. Now that's the first thing about the unsigned. Now the second thing about size and magnitude format. Size, magnitude, right? Size, magnitude, that means you have the size. The name tells you have the size and magnitude. Size and magnitude. What is the size? Size, that means you have negative or positive. Right? And the magnitude is how far it goes to the 0 here. Right? So we think about, you have negative 7 here, and you have the positive 7. They have the same magnitude. Make sense? You can think about that, absolute value, right? Absolute value. If you have negative 7 and you have positive 7, and if you take the absolute value, they have the same value 7. Okay, the sign is a positive or negative, and the magnitude you can think about is the absolute value. Make sense? Okay. Now that is a way you understand about the sign and magnitude, right? Now, what is it? If you work the size magnitude, the leftmost bit is reserved to represent the size. The leftmost bit is reserved to represent the size, and other bit represent the magnitude or the absolute value of the integer. Right? So think about this one here. If I want to store the decimal number positive 22 in 8-bit memory location using the size magnitude here, how I do it? Here's the process. If you work with the positive, If you work with a positive here, it's very simple. Positive very simple. You just convert it into the binary. You just it convert into binary here. Now, this is 8-bit memory, right? So you need 7 bit used to store the magnitude. So see, you have 1, 2, 3, 4, 5 already. You need 2 more bits 0 here to make it for the 7 bit magnitude. Right? Now the left more bit here is for the side. It's for the side, right? So you see the number positive, you add number 0 to the left most place here. Right? So we need 1 more 0 here, and this one it is the positive side, and this one mark it here. Make sense? So it's very simple. It's very simple when you work with a positive number. So basically, if you work with positive number in the case of sign and magnitude here, you just normally convert it into the binary, and you insert every 0 on the left, because is even the left mode bit here is also 0 because of the sign positive. Make sense? Make sense? Okay. Now my question again: if I want to store the number, think about it. If I want to store the number 12 here, if I want to store the number 12 in the 8-bit memory with the sign magnitude, again I have to convert it into the binary, right? Right? And 8-bit memory, I insert every 0 on the left because the sign also 0 here, right? So you just need more 0, 4 more 0. Make sense? So in the case of the positive principle. Now, what happens if you work with a negative here? In the case of negative, right? In the case of negative, again, you take the absolute value. See, if you have negative 19 here, right? You take the absolute value of the negative 19. It is a positive 19 here, right? Make sense? And you convert it. You convert it. Now, you see, you have 1, 2, 3, 4, 5. You need 2 more bits to make it up for the 7 bit. And this one 16, sorry. This one 16 here, right? Okay, 16, sorry. Okay, so see, for this one, you need to store the negative 19 into the 16-bit memory. Right? The first step, again, you have to convert the absolute value or magnitude here into the binary. So you have this guy here, right? Now, with 16-bit memory, you have 1 bit of size, right? 1 bit of size here, and you have the 15-bit left. 15-bit left, right? Make sense? So you see, you have to insert here. So you have to insert all of 0 here to make it up the whole thing here. 15 bits. Right? Now you only have 1 bit on the left, it's the side bit. So in the case of the side bit with the negative here, you add number 1 here. That's all. You add the number 1 to make it up for the sign magnitude. So how we translate it? Check it out. This one negative. Right? And convert everything here into the decimal. You have 19 here. Make sense? Okay. Now I give you the example here. If I have the number here, if I have number 0, 0, 0, 0, 1, 0, 1, 0 here. Now tell me, what is the value in the decimal if I using the sign and magnitude format? What is a
10.
value, right? This one, it's this one too, 10. Make sense? Good. Now, if I have the number here, 1, I have 1, 0, 0, 1, 1, 0 here. Tell me, what is the value of the decimal in the sign and magnitude? How about this one? To make it simple, I just change it. Now, see, tell me, what's the value of this one in the sign magnitude? Tell me. Guys, okay, I see many of you online here. I expect that you actively engage in the class here and tell me what is the value of this one.
140.
Sorry,
140.
Second, what is your answer? No, 140 is not correct. So tell me about this one. Now, in order to convert this one, right? The first thing you have identified. What is the sign here? Positive or negative? Yes. The leftmost bit here, right? You see the leftmost bit here. The leftmost bit here, number 1. Negative. Make sense? That's all. Negative here. Now, you convert the whole thing here into the decimal. What is it? 0, forget it. Right? This one number 8 here. This one number 4 here. This one 0, 0 here, right? So, you add them up together, you have 12. So, basically, this one is negative 12. Make sense? Make sense or not? You want me to explain it again?
So the second, like to the right, I thought that would be.
Now see, this one, the column here, number 1, column here, number 2, column here, number 4, column here, number 8, column here, 16, and so on. Let's double it. Yeah. Make sense?
Yeah.
Okay. So yeah, that's the case you convert this one here, right? That's the case you convert this one. So remember, when you work with the sign and magnitude here, the first thing you have identified what's the sign, positive or negative, right? If positive, then convert it normally. If negative, reserve the sign here and convert the remaining bit into the decimal. Make sense? Okay, the same is this one here. You can see the process here. You can see the same process. If I want to convert this one back to the decimal, I do the same process here, right? The bit here is the 5 bits, negative, right? And I convert the whole thing here into the decimal. I forget everything about 0 here, right? This one, number 1. This one, number 2. This one, number 4. This one, number 8. This one, number 16. Right? 0 here, 0, 0 here, 0. This one I have 16 here. This one I have 2 here. This one I have 1 here. And when you add them together, I have 19. And I have negative here. I have negative. That's why I have negative 90 here. Make sense? Okay? That's the way you convert it. That's the way you convert it using the sign and magnitude format. Okay, now. What is the problem with this one? It's the sign magnitude. You have a huge problem with the sign magnitude because you have 2 ways to represent the number 0. Now tell me what's this one. If I have the number here in the 8-bit memory 0, 0, 0, 0, 0, 0, 0, 0. What do you think? What is the value of this one? In the decimal?
0.
0, right? Now 0. Now if I have 1, 0, 0, 0, 0, 0, 0 here, what's the value of this one in decimal?
0.
Yes, right? Because the number 1 here is negative, right? And everything here 0 again. So we see for the one single digit of 0, you have 2 ways to represent it. It's very confusing in the computing, right? That's why they don't use the mark and they do not use sign and magnitude in the way represented in the computer. But you need to understand it. You need to understand it in order to understand about the what is it about 1 complement and 2 complement. Later I explain it here. Okay, so now see in the problem of 0 here, you have 2 ways to present number 0, right? All of them number 0, or you have number 1 and 7 of them number 0 here. So you see, for 1 single digit, you have 2 ways to represent it. It's very confusing here. That's why computer never ever using this one. Now, so you know that you have the unsigned integer, right? You have the size and magnitude integer. Now the next definition is the 1 complement format. So in the case of 1 complement format, It's quite the same. It's quite the same here. If you work with a positive number, it's a converting number because it's number 0 here. It's a sign here, right? You just convert it number and you insert every 0 before that. So for every format, even that you have unsigned or signed magnitude and one complement format, or later on you learn about the two complement format. When you work with a positive number, it's always the same. Insert number, convert it, and you insert 0 at the beginning. That's all, right? Now, for one complement format here, if you work with the negative number, if you work with negative number, right? If you work with negative number, you convert the positive number into the binary and you reverse this one. I reverse this one, right? So think about this one here. If you want to convert the negative 37 here into the one complement memory here. So what's the process? I do the positive number, right? I convert it here. Right? Now you use 8 bit, right? You use 8 bits. That's why you see I have 1, 2, 3, 4, 5, 6 already, right? So this is the negative number. So the most left bit here, number 1, because it's a sign negative, right? Now you need 1 bit for the sign. You have the 7 bit left. That's why 1, 2, 3, 4, 5, 6, 7. I have to insert number 0 here to make it 7 bit. Right? And in the case of the negative number for the one complement here, you have to reverse it. So every bit in number 0, you convert it to number 1, and every bit in number 1, you convert it to number 0 here, right? So that's the case. So that's the case here. Now see, you convert it. You have 1 here, you have 0, you have 1, you have 1 here, you have 0, you have 1 here, and you have 0 here. And of course, you see the leftmost bit here is number 1 because it's a negative number. Make sense? That's the way of the one complement here. You just reverse everything from 0, you revert it to 1, and 1 you revert it to 0. Make sense? Okay. Now I have a question for you again. If I want to represent the number 15, positive 15 into the one complement. Eight bit memory. How I represent it? How we need to represent it? Number positive 15. I want to represent it 8 bit memory use a one complement. How I do it? How I do it? How I do it? As I mentioned, if it's a positive number, do it normally. Just convert it normally for every format. So 15, how we convert 15 in the binary? You have 1, 1, 1, 1. 8, 4, 2, 1. Now you have 8 bit memory. So you know that for the positive, you just do it normally. 0, 0, 0, 0 here. That's all. And when you translate it, you know that this guy here positive. Now positive here. And everything here, you just convert it back to the decimal. You have 15 here. Make sense? So if the positive number, the format is always the same. You just normally convert it and add 0 at the beginning on the left here. Make sense? Now, my question here, what happens if I want to represent the positive 15 in one complement in 8 bit here? What is it? How we do it?
So you reverse it to 1, 1, 1, 1, 0, 0, 0, 0.
Right? That's it. The first step you do the 15 here, right? You have 1, 1, 1, 1 here, right? And you need that only. You need 3 more 0 here, right? That is a positive 15 for the 8 bit. Of course, the last one is negative. You have number 1 here, right? Now, for this one, you remember that you have to reverse it. So you have to change it to 1, 1, 1, and 0, 0, 0. That's all. And of course, at the beginning, you have 1 here. Make sense? Okay, that's the way you work with that one complement format. Clear or not? Okay, clear, right? Now, again, you have how to do that. Again, for the one complement, you also have to from the 0 here. You have 2 ways to represent 0. Now think about this one. If you have the 8-bit number 0 here, see when you translate it, right? When you translate it, this is a positive. And positive, you just convert it normally. You just convert it normally, and you have 0 here. But what happened? You have 8-bit number 1 here. Again, you translate it. This number 1 here, negative. You have negative here. You know that when you work negative, you have to reverse it. Because it's one, you have to reverse it. That's why you have 0, 0, 0, 0, 0, 0. That's why, okay, you have negative 0. Right? So see, for one number 0, you have 2 ways to represent it. Okay, it's not a solution for the computer to store the number here. Make sense? Okay, and all the way we come from the unsigned side magnitude and the one complement here. You need to understand it in order to understand about the 2 complements. Okay, now see, so you work with the unsigned magnitude, you work with the one complement. Both of them, they have problem of 0 number here, right? You have 2 ways to represent for the number 0. That's very confusing the computer. Now we go with the 2 complement here. So what's the 2 complement? Well, sorry, what is the 2 complement? So for the 2 complement integer, the positive number always the same. It follows the same, exactly the same. You just convert it into the binary and insert number 0 on the left to make it for the full memory here. Right? But if you work with the negative here, if you work with the negative, what happened here? The first thing, you have to convert the number to binary and by the one complement first. And you add the number, sorry, you add the binary number 1 to the one complement of the number. That's the second thing. And if the result is have extra bit or is the overflow here, right? You have to discard the leftmost bit here. That's all. Now, I give you example here. Again, if I want to convert the number positive 15 into the 2 complement, follow the same rule, right? I just convert it here. 1, 1, 1, 1, and I insert 0, 0, 0 here. That's all. When I translate it, I know this one positive, right? And I convert this one back to the decimal, I have 15 here. Okay. Now, if you work with a negative number here, sorry, if you work with negative number, now tell me what is a negative 15 in one complement. The first step here, you have to find the one complement. What is negative 15 in one complement? 8 bits.
One complement, so 1, 1, 1, 1, 0, 0, 0.
Yes, that we did it before, right? So you see, you know that 15 here, you have to convert it 1, 1, 1, 1 here, right? Sorry, you have 1, 1, 1, 1 here, and you need to insert the 3 more 0 to make it 7 bits, right? And the negative, you have the number 1 here, right? Now, if you want to find out the one complement, you have to revert it. You have to revert every bit here. This one keeps the same, number 1 here, but you have to reverse this one. 1, 1, 0, 0, 0. That is one complement of negative 15. Now the next step here, you have to add the number 1 to the one complement here. So how you add number 1 here? You have 0, you have 1, you have 1, and have 0, 0, 0, 1, 1, 1. This one have no extra bits. That's why I keep the same. That's all. That's the way you work with 2 complements of that number. Is that?
So if it's negative, you just add 1 to the number
Yes.
On the right side.
Add 1. You see, add binary 1 to the 1 complement. You do not have extra bit here. That's why you do not have the discuss the level bit. Okay. Now, if I look on this one, if I want to know what is the number here, let's say I do the same follows. I do the reverse here. This one negative. I change this one negative. This one I know that negative here. I have the minus 1 here. I have the minus 1 here. I do the process here. I have 1 1 1 0 0 0 0 here. And I know this is 1 complement. I have to revert it. That's why I have 0 0 0 1 1 1 1 here. And I convert this one. I have 15. That's why I have negative 15. Make sense? Now, okay. So now see what happened here. You know, sometimes you have to add the number 1, right? That's why I want to explain how you add number 1 in the binary here. So what happened if you have the number 1 plus number 1 in the binary? What do you have? What do you think? What do you have for this one?
Negative.
No, 1 plus 1. What do you have?
2.
You have
0. Carry the 1.
Yes, right. That's right. Now 2 is correct. 2 is in the decimal. Yeah, but here is binary, right? I'm working about binary. Binary here. You know that binary only have the 1 and 0. You cannot have 2 in the binary, right? So basically for this one here, 1 and 1, you have 0 and your carry out 1. The same when you think about the decimal number, right? When you have 5 plus 5 here, right? You have 0 and carry out 1 here. That is decimal. But in the binary, you cannot have number 2. Number 2 already overflow here, right? So that's why you have the 0 and carry out 1. And now to make it simple, you understand here. You have 1 plus 1. You have number 2. You are correct in decimal. And you just convert number 2 here, 1 0 in the binary. So you understand that, right? See, 1 plus 1 number 2, and you convert it binary. I have 1 0. That's all. See that? Now what happened here? If I give you another example here. If I have 1 1 1, I plus 1. What do you think? What number I have? What number I have?
1 1 1
1 1 1 1. Okay, now see. 1 plus 1, what do we have? 2. So what is 2? Yeah, so that means you have 0 and carry out 1 here. Right?
Okay, so it's 1 plus 1 0.
Yes. So see, 1 and 1 again, you have 0, carry out 1 here, right? And 1 and 1, again, you have 0 and carry out 1. So actually you have 1 0 0 0. Make sense? Okay, that's all. And of course, you can do it again. This one you have 7 here. This one you have 1 here. And this one you have 8 here. That's all. Make sense? 1 and 1, you have 0 and carry out 1. That's all. That's the way you do it. Okay. Now, so we go a long way with the unsigned integer, sign magnitude integer, 1 complement, and now 2 complement. So now see, if 2 complement solves the problem of the 2 way to represent the number 0 or not, that's very important here. So we see, if in the case if you want to find the 2 complement of the integer, again, if positive, follow the same rule. Let's do it normally, insert 0 on the left, right? Positive here, nice thing about the positive, you have to convert the magnitude here into the integer, right? And add number 0 here to make it up for the 7 bit, right? And now you have to reverse everything here, right? Reverse it. 7 bit here, and the last small bit, you have number 1. That's why you have this one, right? Sorry, you have add on the 1 to the 8 bit. Alright. This one you have to keep the same, and you have to reverse the other one. Now I do it again. Sorry, I make it confusing with this one here. Now, if you want to convert the negative 43, right? The first step you have to convert this one to the binary, right? Binary, right? Add 0 to make it 8 bit here. Now it's negative. You have reverse everything, right? You have reverse everything here. Reverse everything. Reverse. And the last one, you add number 1 because this one. Right? Make sense? Okay. Now see, you have come a long way, all the way with the 2 complements to understand the process of computer store the negative. Right? So see, it's a negative. If you want to know how about this one, you can watch at the slide here. You can read a slide, but the process will follow the same. But I just want to explain about the 0 solution. Why the 2 complements actually address the problem 2 ways to represent number 0. And so see, in the case if I want to find the positive 0 here, at 8-bit memory, you know that positive, you just convert it memory. I have all of them 0 here. Now, what happens if I have negative 0 here? So if I want to find the negative 0 in the 2 complement, the first one, you have to convert it to 1 complement. Right? So we know that in 1 complement here, you have 1, 1, 1, 1, 1, 1, 1 here. 1, 2, 3, 4, 5, 6, 7, 8. That is 1 complement 0. Right? Because you see, negative here, right? And 1 complement, you have to convert it, reverse it here, right? So you have 0, 0, 0, 0, 0 here. So that is a negative 0 in 1 complement. So that is a 1 complement, negative 0 in 1 complement here. Now you know that if you want to find out the 2 complement, you have to add number 1. So what happened here? You add number 1 here. What happened? 0 carry over 1, 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 0 carry over 1. But you see, if you have extra bits, you have to decide. It's a rule in the 2-way complement. You see, you have 8 bits here already. This one is extra bit, you discard it here. So you see, you have to represent negative 0 is 0, 0, 0, 0, 0, 0, 0. Exactly the same with the way of the positive. Make sense? So you see, you come a long way just to explain of the 2 complements. And that is a solution. You can address the problem of 2 ways to represent the number 0. Make sense? Okay? So basically, for the computer, in order to store the negative number, normally they have to work with the 2 complements. That is the only way they can address with the 2 way to present the number 0. Any question, guys? Okay, now so we see, you know everything about how the computer stores the number, integer number, right? You have unsigned number, you have the size and magnitude, you have 1 complement, and you have 2 complement, right? And only 2 complement is the way you can store for the number 0 with only single solution, right? Now we come with the floating point. So we see, sometimes you want to store the floating number, right? It's not something about have the 15.7 or negative 20.5 and so on. Sometimes you have to work with the floating point, right? So the floating point number, it have both integer and fractional part here, right? Okay, so even that the fractional part is 0, it is a floating point. So you see, if we have the 7.0, it's not integer number. It is a floating point number because it also has a fractional part here, right? Okay. So to represent a floating point number in binary, you just divide the number into the first one is the size, the second one is a whole number or integer number. That's what you learned already. The size you learned it. 0 is a positive, 1 is negative. And the whole number you learned it already. And now the last one is the fractional part. So how can you represent the fractional part? Let me explain it to you. Integer part, right? Integer part is just doing everything normally here. You have the number here. Now for the fractional part, you need to understand the process here. Let me share that thing. So basically, if you work the decimal number, You work with decimal number, you have to understand about the position of the column here. Everything starting is a 10, 0, raised to the power 0 here, right? 10 raised to the power 1, 10 raised to the power 2, 10 raised to the power 3, and so on. Now, if you work with fractional part, this one 10 raised to the power -1, right? 10 raised to the power -2, and 10 raised to -3 here, right? That's the process in work with fractional part here. So think about this one. I have 17. So 17.52 here. So what is it? This one in the column 10. Right? That's why I have 10 here. Right? This one 7 in the column number 1. I have 7 here. This one happened. What happened here? This one 10 raised to the power -1. Actually, I have 0.1. Right? Or 1 over 10. 1 over 10. Or 0.1. Right? So actually, I have 0.5. This one 10 raised to the power -2, actually it is 1 over 100, right? Or 0.01, right? That's why I have 0.02. And when I add them up together, I have 17.52. Make sense? Right? Now, that is for decimal. The binary follow exactly the same. The binary follow exactly the same here. So think about the binary. Okay. I think I should better change it to the right here. Now for the binary, this one 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, and 2 raised to the power 3. This one 2 raised to the power -1, 2 raised to the power -2, and 2 raised to the power -3. That's it. Now what happened here? 2 raised to the power 0, you have 1. This one column value number 2, this one number 4, this one number 8 here. This one 2 raised to -1, that means 1 over 2. That means you have 2.1. This one 1 over 4, you have 0.35. This one 1 over 8, you have 0.135 here, and so on. That's all. So what happened here? If I have the number in, let's see what happened here. If I have number, let me give you the number here. If I have number, see, I have number 1, 0, 1, and 1, 0 here. What do you think? What is the number in the decimal? What is the number in decimal for this one? What's the number in the decimal place? Now, translate it. This one, this column number 4, right? I have 4 here. I have 0 here. I have 1 here. That is an integer part. So it's an integer part. Actually, I have number 5. 4.15, right? This one, I have 0.5 here. 1 of 0.5, that means I have 0.5 here. 0.5 here. This one I have 0 here. So actually, for this number, I have 5.5. Make sense? Okay.
What do you get 5.5?
Okay, let me explain it again. Number 1 here in the column 4. Correct or not?
Yeah.
You have 4 here, right?
Yeah.
Number 0 here in column 2, that's why you have 0 here. Number 1 here in the column 1, you have 1 here. And you know that this is where you have to, everything here is the fractional part. And everything from here is the integer part. Sorry. Make sense?
Yeah, I see that.
Okay, so now you see 4 and 1, you have 5. Yeah. And this one, you have 0.5. Right? So when you add them up, you have 5.5. That's the way computers store the fractional part. Make sense? Okay. Now I come back to my slide. Okay, so it follows exactly the same. The same rule here, right? You see on the right, the first column here, -1, -2. I see 2 raised to the power -1, 2 raised to the power negative 2, 2 raised to the power 3, and so on here. And we solve that 1 over 2 here, 1 over 4 here, 1 over 8 here, 1 over 16 here, 1 over 32 here, and 1 over 64 here, and so on. That's all. That's when we work it here. 2.5, 2.35, 2.135, and so on. Alright? This is so on. Keep doing it, you see. Keep doing it, keep doing it, keep doing it here. So now how to convert it? Now, that's what I explained it to you, right? You have to remember about the chart here. The first column, 1.5, the second, half of it. The third one, half of it. Let's see. Alright. This one, 1.2. Alright. Divide half of it, 1.4. Divide half of it, 1.8, 1.16, and so on. And see that we have the every column here. Alright. So now see what happened here. If I want to convert this one here, right? If I want to convert 0.4 into the 6-bit memory, 6-bit binary number here. So what is it? Now, in order to make 0.4, I don't need this 0.5, right? That's why I put 0 here. In order to have the 2.4, I need 225 here, right? That's why I put number 1 here. So when I have the 225, I subtract it, I have the 215 left. Right? In order to make it up for 215, I need 135 here. Right? That's why I put number 1 here. So I minus it, I have this guy here. Right? Now, in order to make it up for this one, I don't need this one. Right? And so on. So on the process here you can see. And remember that you only need 6-bit number here. So you have 1, 2, 3, 4, 5, 6. Right? Okay, that's the process. You convert in the fractional part here. And last on, when you want to convert them together, sorry, if you want to store the decimal number here, 75.804 here at binary, right? You have 2 portions. You have the integer you just do it normally, right? And for the fractional part, you can convert it and put it here. Right? Okay. Again, this slide here, normally you just do with the sum of the homework, and we not go into detail too much about that. That's why we have a lot of calculation. I just want to tell, I just want to mention about the way you convert it, and you should understand about this one here, but you do not have to go into detail much about this. Any question? See, you can see about this one. If you want to work with this one, right? In order to make it up for the 0.805, you need this one, right? That's why I put number 1 here. So you subtract it, you have 0.3 left here. In order to have the 0.3, I need this one for sure, right? So I put number 1 here. Now I minus it 0.024, 54 here. I don't need it because this one less than, right? That's why I put number 0 here. I don't need this one less than. Now I want to store it, right? I want to store it the 4 bits, right? That's why I have 1, 1, 0, 0. Make sense? Okay. So I think that's all for the lecture. I did it everything with the lecture, right? And let's see what you have for the homework for this week. Now for this week, base number, right? So base number, you know that. For this one, you learn about binary, you learn about decimal, you learn about hexadecimal, you learn about unsigned integer, signed magnitude integer, right? 1 complement and 2 complement. You just bring all of them into your discussion if you want. And for the base number, I explained it already, everything you can do it. Now, work with the debugging exercise. So again, for the debugging exercise, you have to understand about the mainline logic. You have to understand about mainline logic. Okay. So the first thing, whatever it is, whenever we work with the pseudocode or whatever, you have to understand what is the requirement of this one. Right? So basically, this one here, you can see, it determines where the students here. Right? That means many students. Right? Many students. Pass or fail. Right? Student need to average 60 or more for the two tests. So basically, for this one here, you have many students. You have many students in this program, right? Again, you can think about this one here. You have student number 1, you have student number 2, and you have student number 3, and each of them they have two tests, right? You have the test number 1, or first test here, test number 1, and the test number 2. Okay, so here is follow the same process with the mainline logic. Now the first thing, tell me more. What is the variable who controls the loop?
First test.
Yes, you see the keyword here, y here, right? And that is the keyword. That is the variable who controls the loop here. So basically, for this program, keep asking user enter the first set and second set of every student, right? And if you want to quit it, he enters the first set of the student to number 0 in order to quit it. Okay. So now see. So if you look on this one, what's wrong with this program here? What's wrong?
The first test is inside the loop.
Yes. Now you know that the first step is the one who controls the loop, right? So know for sure you have to initialize. You have to get the value of the variable who controls the loop before and outside the loop. Right? Okay. Now that's the first thing. What else? Now see, when you got the first and second, you find out what's the average. And you work the selection here. If greater than, you put the pass. If less than, you put the fail. Now, what else? What's wrong? What's wrong here?
You don't have the first test at the bottom of the
Yes. Actually, you have to move at the end, right? At the end, in order to move to the next student or in order to exit program. Okay, that's good. That's good. And you see, for this one, the first thing you have initialize the first step here. The second thing here, actually, you have to move everything here. You have moved everything here at the end, before the end of it, in order to move on to the next student or exit the program. Right? That is the main line logic you should understand about this. And you can do it with the Python if you want to check what's wrong with this one. What else? Okay. This pseudocode intends to display employee net pay value. All employees have standard multiply deduction from the check. If employee do not earn enough to cover deduction, an error message is displayed. So again, for this one, you have to work with the multiple employee, multiple employee here. So you should understand the logic of this program here. It keep asking you what is the name of employee, keep asking you what is the name of employee, and the program will stop if the user enter ZZZ here or and name here. Keep asking it. So what wrong is this program? What do you think? What do you think? What wrong is this program? The first thing, what do you think? What is the variable who controls the loop here? Who controls the loop? Who controls the loop?
While net.
Is that correct or not?
I'm assuming no. Now.
Now, let me explain about this program, right? This program keep asking user enter name. And whenever he enters ZZZ program terminated.
So name.
Yes. Name is the one who controls the loop. Right? So what wrong with this one? What wrong with this one? This one you cannot have if here. Right? This one actually you have to put Y here. Yeah, because you keep doing it with the multiple employee here, right? So basically this one here, you have to put the Y here. Right? you have to put a y here. Alright, for each employee, you figure out what is the net here. What is the net here? Now, in the case of net, you find out net here. You have in the case you have net here, right? In the case you have net, you have you have to find out. You have to deduct it for the deduction, right? Okay. Now, in the case of deduction here, if you take deduction, what happens if you have net greater than 45? You just deduct it, right? You just deduct it. You have the net minus 45 here. But what happens if you have less than 45? You have to print it out, right? You have to print it out. Deduction not cover, net is 0. You change it to 0, right? Okay. So see, this is the case of the selection. If else, you cannot y here. Why that means keep doing again and again. This one you only have the 2 branches, greater than 45 or less than 45. Right? So basically for this one here, you cannot use a y here. You have to check for the if here, right? And else here, and of course you have and if here, and that's the end here. Right? Okay. I hope that you understand the logic of this one and do it with the single code. Okay, this one work with modularization. Right? Modularization. So you have housekeeping, you have main loop, and you have finishing. Right? So again, this one quite the same. This one quite the same with the previous one. But this one they work with the modularization. Okay. Now tell me what's wrong with this one? What's wrong with this program? What's wrong with this program? You break it down in the housekeeping, you break it down in main loop, and break it down in the finish here. What's wrong?
So in the housekeeping, there's no input.
Yes. So no. But now the first thing you have to translate in the main logic here. In the main program. In the main program here. What's wrong? Now this one declaration. What's wrong with this one? What's wrong with this one? Now, let me ask you a question. What is the purpose of housekeeping?
To initialize the
Yes. Right? Initialize the variable who contribute, and you need to do it only one time. Right? Okay, so if you do it only one time, why do you have to use the y here? You have no reason to use the y here. You just need to do it one time only. Right? So this is not correct here. Okay, and okay. When you call housekeeping, you see housekeeping, you have the prompt and you have to store it with the input here, right? Now you come to the y here. You know that name is the one who controls the loop, right? And you see what is the main loop here. What happened in the main loop? You see that you have everything is correct. Right? And again, finish also. Finish only print it out one time, right? Do not use the y here for the finish. Right? Okay. Okay, this one also, it expected you have to follow the main line logic. You have to now you keep enter the number of mile, right? You keep enter the number of mile until the user enter number 0. Right? So every time how many mile and how many gallon, and he divide and to find out, right? Okay. Now if you look on this program, the first thing you have to think, you have to follow the main line logic. Right? And tell me what is a variable who controls the loop here? What is the variable who controls the loop for this program? Yeah, the condition here. In the flowchart, is look it up in the condition here. Right? The mile is the one who controls the loop and keep doing it until it enters 0 here. Right? And you know the mile to control the loop, you need to get it. You need to get the prime input before and outside the loop. Right? So basically for this one here, you have to move outside the loop. Right? You move to outside the loop, and you see what's missing here. you need to get a new mind, right? In order to move on to the next iteration or exit program, right? You need to get the new. So the three rules only. Initialize the variable who controls the loop before and outside the loop, right? Check the condition of the variable who controls the loop, and you need to get the new value of the variable who controls the loop. Okay. Now, what else? One other. You don't have wrapper for this one, right? Yeah. How about Python? Okay, so see, it tell you, right? Tell you the get input and convert the correct data type for test score and class rank. Right? That's why you have to use with the input function to get it from an user. Right? And you have to convert it into the correct data. So basically for the test score, you convert it into the float, right? That's right. That's right. Again, this one is very simple. See, they have the housekeeping, you get the year, month, and the day. Okay, so we have the input, right? You have the input function to get the year, get the month, and get the day from user. Okay, and then in that case, it's at the end, right? At the end, you have to use the print function here. Right? If true, you print it out, it's valid. If not, print it out, not valid. That's all. That's okay. But one thing I have to admit that they are not consistent with the homework because we have not learned about selection yet, right? We have not learned about the loop yet in the Python. Why they asking you what it is? That's something I can observe here in the Python. But anyway, the logic is very simple. You can check it here, and they have the minimum years. Minimum years 10, minimum months 1, and maximum 12, and minimum days 1, and maximum day 31 here, right? So in the case, if user enter the day 35, it will be printed out the invalid here, right? That's the process. So I think that we still have the time, and if you want, you can go with I recommend is that for this one you should work with the Python, right? So you follow the process, you should work with the Python. You can see what wrong with this one, the Python. And I strongly encourage you to work the Python here because later on when you learn about the at 140, you work with a lot, right? And for this case, in the case you work with this one is the Python. Again, this is a very line logic. You have to identify what is the variable who controls the loop. You have to initialize it, right? And you can work this one with the Python. if you want, and if you need any help from me, I can help with the Python. Do it by your own with the Python. And if you're done, you can share screen to me. And if you have any problem with your Python program, just let me know. We have time here to help you. So you can open your Python and work this one with the Python. Remember that in the case of this one, you have to follow the process of the mainline logic. So I can do the same, right? I can do the same when I want to convert this one to the Python. And let's see. I can follow the same. I just copy it. The Visual Code will tell me what wrong. For my first set. In the case of Python, if you want to check not equal, you put this one here. That is the format. That's the format, not equal to 0. And remember that at the end of the while, you will have double stopping. That is. So see, for this one, you have so many problems with this one here. For you here. Put here. That's the word. We convert from the C code to the Python, right? The process here. So whenever you see the output, that is a problem, right? That's the problem. And you have input here that you got it from user. So for these two of the command here, when I convert into the Python, I can use single one here. Right? That's the variable. I want to get it from input, right? It's a prompt here, and I want to convert it into the format number. Right? And as the same, I can do the same, yeah. Same. Second class. So after the first and the second, write down what's average here. Now the output you have to change it to the print in the Python. You have to use the function print. If right, so in the case of Python, if you work the if, you have put this one here. And of course at the beginning, see what is the passing? Passing, you have assigned 60. Passing here is a constant. Right? You have to put it outside. Passing here is constant. And then output. Remember when we have the output, you have to pick pass. Else. Okay. So that's the way I convert it from the pseudocode into the Python, right? And now see what happened with this program. You can see what happened with this program here. Now see what happened with this program when I run it. Yeah, I have syntax error, right? And you know why? Because here, you check here. Y percent not equal 0. What is percent? You have not initialized yet, right? That's why you work with the prime input here, or you work with the housekeeping here. You have to get, you have to initialize the value before and outside the loop, in order to check it. So you already have the first step. You don't need it here. You don't need it here. You have first step. You have second step. You figure it out. Now remember that the last thing, here. Last thing, you have to get the new first step of the next student. So program here work supposed to be around that. So the first student, the thing should be better here to make it more sense. Now 60, 70. So average here 65. Check it, average greater than 60 us. Now enter the first score or 0 of the next student. Should be better. I change it here. Or 0. Next. This one here, I change it first score of the first student. So remember that for the prime input, you have to do it before and outside the loop, and do it only one time. Do it only one time only. That's why I only need to score of the first student only. But inside the body here, I need to move on with next student. That's why I had the next student on. So when I run it again, first score here 60, 70, 75. Now I have the 80, I have 90. Last year, if I have 50 and have 40, fail here. If I want to quit here, always tell user how to quit. I quit 0. Make sense? Okay. So we do the same. We do the same process with other pseudocode if you want to convert it into the Python. So remember that in the case of Python here, you use the while loop here, right? At the end, you have to remember you have to put the double stop, right? And you have to follow the indent. Everything here, indent, right? And if you also, you have to move the indent. So normally you can hit the top, right? You can hit the top. That's the but this one hit the top. This one hit the top. This one hit the top. This one. Sorry, this one. Inside the deep one, so you have this one. This one. Hit the top. That's everything in that. This inside the body of the Y. This is inside the body of Y. Inside the body of Y. Inside the body of Y, right? This is inside the body of deep analysis. Right? Remember, that is some syntax you have to follow when work with the Python. Okay. Any questions?
So the end while is only like pseudocode?
Yes, and Y is only pseudocode, not in the Python. And if also, you don't have to work with them. Yeah. That's the logic. That's why you should understand the logic. Once you understand it, you can convert it in real. And for the other one, you use that follow exactly the same, right? You need to get the name. You check the Y here. You check the if here. And that's all. So I think that's all for today. Right? Again, remember that anytime you have any problem, you send inbox me, send me email, join my office hour, or send me your available time. Okay? And I'm more than happy to have you for this because I love my job. I love teaching. Okay, so if you have any question, let me know. Otherwise, I'll see you on next Monday. Okay? Any question? Oh, okay. So see you guys on Monday. And again, if any one of you want help from me, you can stay after the class. You can stay in the Zoom after the class here. And for now, if you want to leave, just feel free to leave. Okay, see you guys. Bye bye.
See ya.